All right, welcome back, everyone. It is day 21 according to our calendar. And we are prepping for 12.6, which is more in conics. And our conics are our parabolas, hyperbolas. And what's the last one? You want to remember the name of the last one?
Ellipses.
Ellipses. Sound like you were gonna say circles. Circles is one too. It's one of the lame ones though. I think it's just so basic. You look at it and you go, you're a basic conic. So what kind of equations, what equation do we have for in a circle? Say that again.
Equals. I thought x plus h squared. Plus y plus k squared.
You had to do minus, because we do the minus.
Minus. And then equals.
R squared.
R squared, yes.
So that's a circle. And the alternative form we have is we put it divide by R squared. So I'll call that alternate form. What about our ellipse?
It's the same, x minus h squared plus y k squared, equals. Is that r or one?
It's one.
One and then over a b squared.
Yeah. So if A equals B, this is a circle. And the closer A is to B, the rounder it is, more circle-like it is. We're going to have a measure of that later on today called eccentricity. Eccentricity measures roundness. I'm curious what my eccentricity rating is. I'm fairly round. And what about hyperbola?
X minus h squared. Minus y minus k squared equals 1 over a and b squared.
So is that a hyperbola that opens up and down or left and right?
Left right.
So this is a left and right one. What about an up down one?
It's y minus k squared over e minus x h squared over h equals 1.
Yeah. Hyperbolas have eccentricity as well, so do parabolas. All right, with that in mind, let's do more stuff with hyperbolas and ellipses, the thing you probably have the least amount of practice with. We haven't done yet, Sarah. I always try to deliver enjoyment.
Another song, please.
What?
Or another song.
You don't want to hear my math songs. I have math songs.
Yeah. I'll be coming on day tomorrow.
When you start taking 54, math 54, let me know when you're like about 2 weeks in, I'll send you a math video,
Okay.
but with a song. It's a lot, I want to say it's based on the rhythm of Poker Face. I think it's based on Poker Face. Maybe I'll play it for you later over break. All right, no one looks like they're ready. Wait, Roberto's still ready. Let me grab a problem from the textbook. That's a good way to not fuck it up. The more I wing it and just make up numbers, I have found that that can lead to catastrophic events. Like in calculus 3 on one of my tests, I had an unsolvable problem. But you had to do a bunch of work to get to that point to find that it was unsolvable. And you're like, oh shit, it's negative and it's distance. That doesn't work. All right, that one's calling to me. Let's do that. We're gonna do x squared plus 9y squared minus 4x plus 18y minus 23 equals 0. So we want to write it in terms of some type of conic. The way to tell the difference between the parabolas, ellipses, circles, and hyperbolas are parabolas only have one squared thing. Everything else has two squared things. If x squared and y squared are both have a 1 in front of them or the same number in front of them, it's going to be a circle. They've got different numbers and they're both positive, it's an ellipse. And if they've got different numbers and one is negative, it's a hyperbola. So this has got different numbers and a positive, this is going to be an ellipse. So let's start grouping this stuff up. I'm going to put the 4x with the x squared. I'll leave a little gap. And we're going to do the 9y squared with the 18y. But I want to factor out the 9. And I'm going to move the 23 to the other side by adding. If I factor out the 9 out of the 9y squared, I get a y squared. If I factor out 9 out of 18, I get 2. All right. So we're going to complete the square. Take that, cut it in half and square it, put it back in. -2 squared is +4. I added 4 on the left, I'm going to add 4 on the right. And here we take the 2, divide it We cut it in half, square it, and we get +1. We have really added 9 times 1. Which is +9.
Yeah.
So the right side adds up to 36. This goes right in the parentheses, x minus 2 squared. This goes right in the parentheses is 1. And I'm gonna move my 36 over a little bit closer. Finally, we divide by 36. And we get. Nine over 36. Is 9 times 4 on bottom. That's gonna simplify to 4 on the bottom. Okay, so where's the center at?
Well, also 2 and then -4. 2x and 4y, -4.
I agree with that. Where are the vertices at? This one's a little harder, so I wouldn't jump into this without drawing a picture. So let's graph this. Like with experience, you could do it, but it takes a lot of experience. I have to stop and think about it. I have a center at 2, 4. Maybe what we can identify is A and B. What's A and B?
Or A is 6. E is 2.
Yep. And what do I do with those to make the ellipse?
6 to the left and to the right.
6 to the left and 6 to the right. All right.
2 up.
2, 3, 4, 5, 6.
Isn't the center -4, not +4?
You're right.
Oh,
Good catch. Good catch. Fuck. And then we're gonna go left 6. That's 2, 3, 4, 5, 6. And up or down 2. And then we draw it. Make it a little rounded. Now that I have a picture. We can find the coordinates of the vertices. But which ones are they? Just in description of the ellipse. Anybody know?
that from 6 all the way to the other.
It's the one that's along here?
Yes.
Yeah, So the vertices are always at the endpoints along the longest axis. The longest axis here is along X, so it's the endpoints, this is vertice 1 and vertice 2. And rather than going with my picture and trying to reason out or figure out where they're at, this is 6 left and 6 right from the center. So let's do that with the vertices. I'm going to do 2 plus 6 and 2 minus 6. So this will be 8, -4. And -4, -4. If you're using like graph paper and you're like precise, that you can look directly at the graph and get it. But if you're not, if you're freehand sketching it like I did, I strongly recommend recognizing, think about what is in terms of the center and making adjustments from there. Do we have any x-intercepts? This should be a really easy fucking question. What's an x-intercept?
We talked about it. It's when the points meet the x-axis.
Yes. It's when our graph crosses the x-axis. Are we crossing the x-axis? No. So there's no x-intercepts. Doesn't cross the x-axis. If you like football, an intercept is when the defender crosses the path of the football at the same fucking time, is in the same location, their paths cross. So think about that, same type of intercept, it's where 2 paths are crossing. In this case, straight line crossing a curve. Which technically is what's happening with a fucking football. If the football, he throws it, he's throwing it in a straight line. It doesn't, they can't fucking put no spin on it like a baseball.
Yeah.
So it's flying in a straight, it may go up and down, but in terms of left and right, it's going straight. Same idea as football. All right, is there a y-intercept? Not what is it, but is there one?
I believe so.
Why?
You set x to 0 and. Wait,
Well, that's how we'll find it, but why do you think there's a y-intercept?
it's crossing the wire. So
It crosses the y-axis. Excellent, that's exactly what we're going for. So there are y-intercepts. Yes. Along the y-axis, x equals 0. So if we wanted to find them. We're just gonna plug in x equals 0. Before I deal with any of that shit, I'm just gonna multiply through by 36. So we don't have any fractions. I've got -2 squared plus 9 times y plus 4 squared equals 36. So -2 squared, what is that value?
or
It's +4. So I'm gonna move it to the other side by subtracting it. And you get 9y plus 4 squared equals 32. You might be inclined to multiply this shit all out and try to do a quadratic formula. But we can just as easily divide by 9 here. Take the square root. And then subtract 4. So y equals -4 plus or minus square root of 32, 3. So that's when x is 0. If I write them up here, I've got -4 plus square root of 32 over 3. And -4 minus square root of 32 over 3. Those are my y-intercepts. Call that A and B. So that's gotta be A, it's gotta be higher up. And that's gotta be the B. Doesn't look like it's an exact whole number kind of thing, so. I mean, if we wanted to actually know the decimal value, we could throw it in a calculator and find it, but. An exact answer, we have an exact answer. All right, the next one we're gonna do, we'll just talk about whether there are intercepts. We're not gonna bother finding them. I just want to remind you guys of how to do it. Give you guys a second to write all this tasty goodness down. Oh, we also went to, for my birthday,
Yes.
Behars on K Street. It's like literally if you go down this street until you get to K and you turn left, Behars is like 6 buildings down on the right. It's a restaurant. We actually, that's my wife's name. We both like eating there. And she found out like a week before my birthday that if you show ID on your birthday, you can have a combo plate for free.
Oh, sweet.
So I went in there and got me a nice 3 combo plate with some enchiladas and sope.
Yeah.
And I still have a little bit left. I didn't finish it because it's a lot of food. But for, free plate that's like $17 or some shit like that.
Yeah. Did they sing for you or no? They sing
No.
happy birthday? Oh. Should have sang happy birthday in class though.
Eh. My wife's saying happy birthday to me.
Oh, that's nice.
And I got a neat t-shirt I will probably wear on, I'll show it to you
Oh, dude.
when I wear it. Someone bought me a nice shirt.
Oh,
And then it to me just cracks me up.
okay. Is it appropriate or is it inappropriate?
It's appropriate. In fact, I think I have it on Messenger. So like I can load up Facebook and show it to you.
So,
No internet connection. Fuck you, there's an internet connection. Oh, my computer's having a stroke. Oh, well, we'll go on and when it's ready to pop up, I'll do it. All right, let's do one for hyperbola. In fact, I'm gonna let you guys work on it for a little bit. And then we'll do it together in like, I don't know, 10 minutes. So find the equation. Find the center. For vertices. And graph it. And since if you fuck up the first step, it's gonna make this really hard. You're gonna make sure everyone's got the same first step in about 45 seconds. Okay. So we factor out. I'm gonna group the x's together. You factor out the 9, you should have that.
Yes.
And if you factor out -25, you should have that.
Yes.
If you got to there, good, you're doing good. The thought part most people might miss is this negative in front of the 6y. Because when you take out the negative out of a positive, it's gotta be a negative. Another 5 minutes. Don't want to take your fun. Sarah looks like she's having a great time.
So on the X and the Y intercept.
Do that in a second. Although I didn't technically ask for it, it is good practice. Everybody ready?
Yes.
I see phones in everybody's hand except Keith and he's leaning back. So. Let's complete the square. Is +4. So this is 9 times 4 is 36. We'll add 36 over here. -3 squared is 9. -25 times 9 is -225. So we'll do that over there. 450 minus 225 is 225. So we have 9 times x minus 2 squared minus 25 times y minus 3 squared equals 225. We divide by 225. 225 is conveniently 9 times 25. So when we divide this one by it, the 9's cancel. And when we divide this one by it, the 25s cancel and we get a 9 on bottom. Right?
Yes,
So, center,
is +2 and X and then +3 Y.
okay. What's A and B?
A is 5, +5, and B is +3, which is 3.
Up and down or left and right?
To the left 5 and right 5 and up 3 and down 3.
I mean, which way is the parabola opening?
Oh, it's going to the left and right.
Left and right, okay. So since the X is in front, we got left and right. So we're gonna go graph it before we do any of the other shit, cause I think it's a little easier to find stuff. So we're gonna make our box, which means going left and right 5. And up and down 3. So I'll do my asymptotes diagonally. And we said it's going left and right, so it's going from these points right here. So with that in mind, where are the vertices?
It's the right, the maximum is 5, so. It's like you said earlier, 5 plus 2. I mean 2 plus 5 and 2 minus 5.
Yeah, we're going left and right 5. So our vertices are gonna be at 2 plus or minus 5, comma 3. So 2 plus 5 would be 7, comma 3. 2 minus 5 is -3, comma 3.
Yeah.
So if I call that one B1 and this one's B2, that's B1 and that's B2.
I feel like, what is the? I'm forgetting something, what is the difference between this and the ellipse one?
The ellipse form has a positive here.
That's
The only difference.
Yeah.
But the hyperbola,
And the shape is drastically different.
it can also have a positive, right, as well, and the parabola.
Well, yeah, but parabola only has one squared thing.
Yes.
This has x squared and a y squared, so
I mean, the
hyperbola,
hyperbola, yeah.
they're not both positive, one is a negative.
I mean, they can have a positive, still, we can still make a, right, parabola.
One of them has to be a negative.
Oh,
So if this is a positive, that one has to be a negative or a hyperbola.
yes,
If they're both positive, it's an ellipse.
okay. People are thinking of bola functions that.
Are there x-intercepts and are there y-intercepts?
I believe there's an excellent, so. And a wire, so.
I didn't know that would be low there, so.
I don't know. One is the,
Wait, okay, so let's do one at a time. X-intercept.
yes,
Does everyone say yes?
Two.
There's two of them, right?
yes.
Y-intercept. I'm getting conflicting responses. David says 0. You had originally said yes.
I'm just looking at the graph and I'm thinking, I don't see them touching the y-axis.
That's exactly what you need to do. This is what I tried to get you guys to do a half hour ago.
No,
Just look at the graph. This is the y-axis. Is the graph crossing it?
no,
No, so there's 0. So if we want to find them, the only two we can find are these ones. They're right here, not right there, they're right there and right there. And so how do we find them? Y equals 0 there. This might be easiest all the way in the top equation. I don't know.
And another thing, a question that might be asked would be
Right here.
there's no, like, if there were a Z. Like line, or there was a third dimension in this graph. There would be no circumstance where they touch that either. Like, if these two things were plotted on a 3-dimensional graph.
That's some next level shit. We would have a z squared in this.
It would still be 0.
Well, it depends on
It depends.
it could cross the z that. Now you start looking at, we'll talk about it over break. Let me finish this. So x equals 0 or y equals 0. I'll just do that right here. So I've got 9x minus 2 squared minus 25 times 0 minus 3 squared equals 225. This is negative 225 right there. So when I add it over, I get 9 times x minus 2 squared equals 450. Divide by 9, I get x minus 2 squared equals 50. We'll take the square root. Plus or minus square root of 50. I don't know why I'm saying it like that. I know. It's fucking ridiculous. So x equals 2 plus or minus square root of 50. So 2 plus root 50 comma 0. 2 minus root 50 comma 0. 50 square root of 50 is about 7.1 approximately. Might be closer to 7.2. I'm winging it. 49 is 7. It's a little higher than it, so it's a little higher than 7. So if I wanted to get like an approximation, 2 plus that would be like 9.1 comma 0. And 2 minus it would be negative 5.1 comma 0. And it looks like maybe if I done my hashtags a little bit better and drawn my hyperbole a little bit better, we would have gotten that. That's it for that section. I pause this or stop recording.